Imagine achieving total energy independence, not with a massive power plant, but with a simple, silent box. Sounds a little like science fiction, doesn't it? Well, today we're going to break down a huge leap forward in solid oxide fuel cell technology that might actually make this a reality. Let's dive in. We have to start here with this powerful reminder. The climate crisis isn't some distant problem for our grandkids to solve. It's here and it's happening now. These disasters, they're a massive wake-up call, really, demanding that we find better, cleaner, and way more reliable ways to power our lives. So that's the big question, isn't it? How do we solve this? We need energy that's clean, sure, but it also has to be constant. It has to be there when we need it. But what if the solution wasn't another giant spinning turbine or a massive solar farm? What if it was a simple, quiet box that could power a home, a factory, or even a whole town with zero fire?
Okay, so this magic box sounds pretty cool, but why is it such a potential game changer? Well, to really get that, we need to first understand the fundamental energy dilemma we're all stuck in.
And this chart just lays it out perfectly. On one hand, you've got fossil fuels. They're super reliable, right? They give you stable 24/7 power. The massive downside, all the pollution and emissions. On the other hand, you've got solar and wind. They're wonderfully clean, no doubt about it. But they're intermittent. The sun goes down, the wind stops blowing, and you're left with this huge stability gap. And this is not just a theoretical problem. Take Indonesia, for example. They're committed to hitting net zero by 2060, which is great. But their grid relies heavily on coal for that stable baseline power. So how do you phase out the coal plants without causing constant blackouts? That's the billion-dollar question. And that brings us right to the solution. The magic box we've been talking about is a technology called the Solid Oxide Fuel Cell, or SOFC for short. And it's specifically designed to fill that critical gap, to give us power that's both clean and stable. So what exactly is it? An SOFC is not your typical engine. There are no explosions, no fire, no moving parts. It takes in a fuel, and through a quiet electrochemical reaction across a special ceramic material, it generates electricity directly. The source material calls it a power plant without fire, and honestly, that's the perfect way to think about it. And the process is just beautifully simple. Step 1, fuel goes in, and it's not a picky eater, which is a huge plus. Step 2, this special ceramic inside does its thing. A silent chemical reaction takes place. And step 3, what comes out the other end? No smoke, no noise, just clean electricity, useful heat, and a little bit of water. That's it. Now let's talk about the advantages, because they are huge. First, the efficiency is off the charts, over 60%. That's more than double a typical coal plant. It's fuel flexible, so it can run on natural gas now and then switch to green hydrogen in the future. It's modular, so you can scale it from a small box for a house up to a full-blown plant for a city. And most importantly, it provides continuous 24/7 power, which finally solves that stability problem we talked about. Okay, so this all sounds great in theory, but technology is nothing without proof, right? So let's look at the recent research that has taken SOFCs from just a promising idea to the next level. So the breakthrough really comes down to this new material, SBSC 55. In a fuel cell, higher electrical conductivity means better performance. Think of it like a highway for electricity. The wider it is, the better. As you can see, the industry standard target is about 100. Well, this new material just blows that away, clocking in at 256. That is a massive leap forward.
All right, next up, efficiency. For this, you want the lowest possible internal resistance. The less resistance, the more energy gets through without being wasted as heat. The international target is to get under 0.1, and this new material scored just 0.064. It doesn't just meet the goal, it crushes it. So it's not just powerful, it's incredibly efficient. And finally, the big question. Does it last? This chart shows the degradation rate, basically how quickly it wears out. You can see competitor materials degrade at a rate of almost 2 to over 3% per 1,000 hours. This new composite material, less than 1%. It clears the bar for commercial use, proving it's actually built to last in the real world. So, the science is solid, the performance has been proven, but how do you take a breakthrough like this from a laboratory and scale it up to actually power an entire nation? Well, for that, you need a blueprint. And here is that blueprint. It's a 4-pillar plan. It starts with material sovereignty, basically using a nation's own natural resources to build the cells at home. Then you target the toughest polluters with industrial decarbonization.
From there, you achieve energy decentralization, bringing reliable power to remote areas. And finally, you tie it all together with regulatory synergy to help speed up innovation. It's a complete, top-to-bottom strategy. Okay, let's bring all of this together. What does this leap in technology really mean for the future of energy? What is the ultimate takeaway here?
This quote really gets to the heart of it. Real energy independence, maybe it isn't about owning the fuel source, whether that's oil or natural gas. Maybe it's about owning the technology. It's a fundamental shift in thinking, moving away from depending on resources to mastering the innovation that powers your future.
And that really leaves us with a critical question for all of us. In a world of climate change and shifting politics, is mastering a core technology like this the true key to a nation's future energy independence and resilience? This breakthrough certainly suggests it could be. Thanks for watching.